So there's a human operator on the inside, but he's got a very degraded network link. He only gets 9600 baud to the robot, and then intermittently he gets more data. So the network will go to high bandwidth for 1 second and then be blackout for 45 seconds and then 1 second on, up to 45 seconds. It's to simulate a degraded network situation. I don't know if you can take that third finger and open it all the way. That might be enough to help.
While research robots can do incredible things that are in all the movies and look just incredible and magical, unified systems that you actually deploy out into a disaster site or into a minefield, those systems are not nearly as advanced because they have to do all of those amazing research things simultaneously, reliably, and in much harder environments.
It's called the DARPA Robotics Challenge. It's a big challenge in 2 weeks where we're going to send this into a set that looks a bit like this and try to show that our robots are getting closer to being capable for disaster response. Say it again. Thank you. They're going to do one more cut. Yeah. The signal's so noisy when the drill's on that we don't use it for force feedback. But we can actually use the force sensors in his feet to feel a little bit how much he's pushing. So he's going to give him high-level commands, and we can see if he can get the plug up and into those holders. But he's never seen or tried that before. He has no rear-facing sensors, so he has to remember from the last time he saw the terrain where it was. Thank you. It's turning. If we were trying to do it for time, we could go through it pretty fast, but we're trying to make sure we don't make mistakes. And we're trying to test them on all these quirks. The other day we had him pick up a telephone and put it, he put it in, I didn't ask him to put it next to his ear, but he did it for fun.
At the competition, it's going to be completely freestanding, which is why we're putting so much work into being able to recover from a wide variety of falls and detecting when we really are inevitably falling and going into a bracing. When we're at competition, there will be no tether, so it's scary and we're preparing for it as best we can.
So Boston Dynamics built the robot. MIT did all the software. It's the Robot Locomotion Group. It's part of Computer Science and AI Lab, and we have students from all over campus.
I'm Greg Izat. I am a first-year PhD student in Russ's lab in course 6. Through undergrad, I studied a lot of different things. I didn't really know what I wanted to do. I wound up studying both neuroscience and computer science, and pretty quickly realized that robotics is where I really wanted to be. And actually, I came over here the summer before last to work with what was originally kind of the foundation of this team. And then went back and finished up my undergrad. And then felt really natural to come back and do robotics here because the robotics here is amazing, and this team was so much fun to work with.
It's incredible what every one of these people have done.
Well, I know a little bit about hardware and software. And
yes, no, absolutely.
It's unbelievable.
Yeah, like that window over there is our process manager.
I mean, I would love to see that robot walking up the steps to Grey House.
Yeah.
Look, I wish you the very best, and this has been amazing.
Good luck, you guys.
We are now 2 days before we ship the robot. We had a crew here super late last night. Crew that arrived first thing this morning couldn't boot the robot. Turns out there was a loose wire in the power, probably from moving it inside and outside a bunch. We have not previously been authorized to open up the computers, but in panic mode here, they're recommending we look inside and see if we can reseat some boards and get things working again.
might have been. This should use the regular. Yeah, I know.
It happens that one of the 4 computers runs. There's a small chance we can run a lot of the processes on that. We might not be fully functional, but we might get 80% functionality for some testing for the rest of the weekend. But that's going to take hours and hours of work and changing our configurations of our known working, optimized strategy to make that work. So we are having a rough weekend.
Bit afternoon now, and they've just managed to resolve the computers. Looks like it's unconnected to whatever happened with the power supply, maybe, which I'm happy about because I was worried that I was the one who had fried our computers and made the robot non-responsive. But looks like we're going to be back in business, so we can actually do those tests that we wanted to do. We go to work in the morning and play with robots. It's pretty cool. We try not to dwell on that too much though, because then our wives or significant others get kind of upset about the fact that we need to go play every day. But yeah, they're happy for us.
The first thing we have to do in the competition is to actually drive the Polaris through an obstacle course.
Yeah, down.
So I've been working on how do we fit in the car, actuate the wheel, actuate the pedal. So that's been quite a challenge because we have a big robot in a little car. And then the second thing that I've been working on with Andres is how to get out of the car.
Slack, slack, slack.
So that's another challenge because we're pretty big relative to the car and also very heavy, so the car suspension moves as we stand on it.
Recovery.
That's a pose, huh? So he probably was told to balance using his feet when his butt was on the chair or something like that, and got very confused. When we started up, we didn't know exactly what the project was going to be about. Given the original description of the challenge, it could have been mostly perception and high-level reasoning. It turned out to be a lot more about balance and control than I originally thought. So it ended up being perfect for my group and my students. Not all of them wanted to participate. Some of them knew that the hours that would be required would potentially get in the way of research. But a lot of people jumped at the opportunity, me included. Actually, the whole time I've been debating with myself and with the students whether this was the right use of our time. But having survived it, I'm extremely happy that I've done it. I feel like we've learned a ton, we've done good research, we've gotten to play with this awesome robot.
We should be able to look at the VRF integrators, and if those are positive while it's standing still, then that's an indication.
My area of expertise is in control, so I designed the underlying control algorithms that we use for balancing and walking. The other sort of part of my job has been to work with a lot of these amazing PhD students and guide them along the development of the fantastic planning and control algorithms that they've developed. We tried to take all of the cool research ideas we developed in simulation and bring them up to speed on a hardware system. And we've been really happy to the extent we've been able to do that and come up with really general research ideas that we think will live beyond this particular project. Can you pressure control is off, right? Good.
The hands are going to look kind of close here. I'm not sure why the speed is so low.
For the driving, the human driver's got a steering wheel that tells him what to do, and the robot just obeys the human. But the egress and most getting out of the car and all these other things, the robot's doing a lot of it itself. The human's just saying, okay, yes, you can do that.
So the robot sits in the car with one leg out, and that's to help it get out of the car easier. And then what it does is picks up its leg and puts it on the pedal. Maybe come up just like 1 inch because you're like just resting on the pedal, and we probably want to be a little off it for safety. And then it reaches its arm over here and puts its arm onto the wheel. Go for the grab. It has a pretty big backpack, so it actually has to sit about this far up just to not hit the backpack. If it tried to sit over in the passenger seat, it just wouldn't be able to fit like a normal human.
It's an almost autonomous machine, but you'll see like 6 people following it, carrying its cables and everything. At the competition, he'll have batteries, but until we get those batteries, when he's driving, he has to be on an umbilical cord.
Nice. Woo! That was really hard. That was really hard. In case you didn't know. All right, put your arms down, buddy.
Just 2 weeks ago, I had my first baby, so his name's Charlie, and he's awesome. And so although we've been working crazy hours here, it's still really great to go home and wake up in the middle of the night and change his diapers and then come back in and work on cool robots. So I think it's going to be really fun for him to see the things that we've done, you know, on footage when he's older and to understand it. But yeah, I think it's been a really amazing month for me personally.
I've got a 9-year-old and a 6-year-old, and they're rooting for the robot, but they miss their dad. It's in Pomona, California, so they've already got a plan to go to Disneyland right afterwards. So I was joking that I hope we win so someone asks me what I'm going to do next.
We have 3 kids. They will all be at the finals. This is a drawing that my 5-year-old Sophia did. She runs around pretending to be a robot at home. For a while she had like wooden blocks that she was using as batteries, and she was tucking them into her socks and into her pockets, and as long as she had enough batteries she would keep going.
I need you to stay on this side of the sign. All the sharp things are over on that side of the sign.
Just like that. Oh!
It's been a pretty busy few days getting things ready. Some early mornings and late nights, but yeah, things are going pretty well.
It's been really, really fun and inspiring working around this building, and I keep telling my friends at home that I think I'm working in what must be one of the coolest buildings in the world right now. Every time I walk in and out, I walk past 10 of the most advanced, coolest robots in the world being worked on by tons of the smartest roboticists that you can find. It's inspiring, it's really fun, and it's kind of scary.
I think the main competition is Chimp, which is the Carnegie Mellon NREC team, and IHMC, which also has an Atlas. I think those are our 2 main competitors.
We've been working like crazy around the clock here this week. Did a little practice with the batteries for the first time yesterday. We scored 8 points in like 40 minutes, which is enough that everybody, I think, is watching us now and trying to maybe thinking that we're a team to possibly win. So we're feeling pretty good. And you can see he's kind of holding on to the, and then when we walked through the door, I mean, wow, that was awesome.
Face of the whole wall, get a scan of everything, and
we're taking it really safe for this practice run right now. We're gonna basically go in and drive a little bit, not do anything that's gonna make the robot possibly fall. We're not tethered, there's no gantry. If we fall, we break today.
Our goal is not to do all of the tasks, but to collect some additional data about some of the variations that we weren't able to reproduce inside our lab.
The important bits for us are the valve, which you can kind of see hints of here, a set of drills and a drill wall, a surprise task, which is just this little box, the terrain course and the neighboring debris course, and then you can come out this door and go up these stairs. And then mind you,
there's actually one right here, actually.
Was down under the robot, keeping an eye on the center of pressure. So this has to remain within the foot that it's standing on at all times, or it's going to fall over. So I just watch this button and I hit reactive recovery trigger if we look like we're going to fall, which we never did.
Had a few hiccups, but I think it's good that we had them today versus tomorrow.
I'm a mixture of nervous and excited, I think. Today was a big rehearsal day for all the teams, and we've seen some really impressive performances by some teams. People are doing a lot of the tasks a lot faster than I think we expected. We thought we were, doing really, really well to be completing the tasks in 45 minutes, and we had word that, some other teams might be doing them in 40 or 35.
I think it's a speed game at this point, who can do it the fastest. So Keist, which is a Korean team, weren't really on our radar, but they got all the points today, so they can definitely do it.
I think we can definitely do all of the tests as well, but if there's a tie on the number of tasks that you've completed, it gets broken by the time it took you to complete the tasks.
I think this is going to be a lot of fun, no matter how it turns out. I think we have some really good competitors, and I think we're going to put on a show for everyone.
Hands in on 3. On my team. 1, 2, 3.
Right, good robot, let's go.
Something fell off the script during egress, and we fell on our face. We fell on our face, and the robot was still okay. It was still reporting back to us. It hadn't been e-stopped. The arms were still recording state, which means they hadn't fallen off and they weren't sporting oil everywhere. So we were not in great condition, but we were okay. We stood back up, and we saw that we had everything functioning except for one joint in our right wrist, which ironically I also can't use. And we spend a few minutes figuring this out while we're waiting through our reset period. Field team does a fantastic job of getting us back up off the ground, back where we need to be to reset ourselves. And we do the rest of the run with a broken right wrist. It was difficult because we've scripted everything to really work with the right hand. We're really right-handed for this. This is a right-handed course. Everything is on the right as we go. And there are tasks like the drill that actually require the right hand, or actually both hands technically. So we had to skip drill, but we can do valve left-handed. We can do surprise left-handed. We just got to work a little bit harder. And so Pat showed off his skills as an operator fixing those up. And then we did terrain and stairs exactly as planned, because we don't need hands for that, right? So it was fun. Wish we could have gotten 8 points, but we know it went wrong, and I think we're going to get 8 points tomorrow. We're definitely going to get 8 points tomorrow.
All right, here's the quick story. We've had the hardest day of my life because we woke up, I got here at 5 this morning, powered on the robot, and it went
Our fall yesterday seemed pretty tame in that we could get back up and keep moving. The trouble seemed pretty well isolated to the right arm, but
We would stay standing.
as we've been going through the repair procedure with Boston Dynamics, we keep finding more issues.
We had various parts of the robot fail on us, power distribution board, hard drive on one of the robot's onboard computers, a network switch that was provided by DARPA.
The robot had open heart surgery at around 8:30, where they ripped it all apart and replaced the circuit board that's at the back. They fixed an arm, a few other things. There aren't any parts left to break.
It really feels like we really just need one final run out of the robot, and we're really begging it for it at this point.
I think we're up now. We will run if we have to.
We had communicated to DARPA that we would like a later start time, but they didn't realize that we had more than one failure this morning. They thought we still had a couple hours to sort things out, so they didn't grant it initially. And by the time we got out there, we talked to a person on the field, and they realized that the problem was a lot more severe this morning, and then they pushed us to the later time. It was a little bittersweet. In one sense, it gives us a little bit more time to relax and evaluate the robot before we send it out to the field. But on the other hand, it's a little bit of an emotional roller coaster that we probably didn't need.
Don't come up. That was the fall. We entered.
So what do we do?
It's not officially.
Perfect. Now come in. Maybe 1 more centimeter. Close. Okay, put.
Wow. All with that robot hand?
I think the mood of the team right now is calm. I think that everyone knows what we're capable of doing tonight, and we expect to execute on what we know we can do. Right now we're just putting the polish on and we're ready to send it out and do the thing.
We had a time when we got to the drill that could have been the winning time. We got the drill on the first button push. He started cutting, the drill slipped away from the wall. And he went around, he did not cut all the way out. It's hard for the robot and the human operator to understand how deep they've gone into the wall. He was suspicious, he went again, tried to cut again, he being the human operator, tried to cut again, but the drill has a 5-minute timeout. So at the end of 5 minutes, the drill stops. He knew that the drill stopped. At that point, it was either 8 points or bust. We knew that if we didn't get all 8 points, we wouldn't win the competition. So he did what he was supposed to do, what he should have done. He started trying to punch the wall. It wasn't close enough to fall, and so it ultimately knocked the robot over. But that was the right thing to do. I mean, he had to try as hard as he could to knock the wall out, because otherwise that was the only way we could win.
We have a good fall detector.
Yeah, and a good robot, really. I mean, it was an easy fall, but right back up. See, we got to test the bracing.
Yeah, the brake is worse. I didn't notice that. Yeah, that's why that's why it went down gently and with the arms.
Our final statement.
We've literally never tested bracing falling before for kind of clear reasons. So it's good to see, that worked. We braced just fine. Nice soft fall on the ground, right back up on our feet, and we just know, okay, this is not going to be an 8-point run. So during that 10-minute reset period, we kind of sat around and was like, okay, what can we do to show off? What can we do that's cool and we like? So we haul right over to Plug, look at Plug, look at our watch. We're like, we have 18 minutes. It takes 20 minutes to do these 3 tasks. Nope. Turn around and walk away.
And we could only do then our favorite tasks at the end, which were the terrain and the stairs.
We book it through terrain. Terrain goes absolutely fantastic until the very last step. Our foot comes down wrong. I just heard from Russ that we clipped one of the cinder blocks with our foot. Our foot snapped off it, and we missed a footstep by what I could see in the plan was somewhere between 3 and 5 centimeters. It sounds very small, but we all knew looking at that, the next step is going to fail. And I hit the reactive recovery button. Everyone's like, oh my God, and it recovers.
That was a good recovery. Who hit that?
Greg.
Greg hit that.
Greg just noticed. From everyone else, it looks like we just kind of hesitated on that last step, and we're waiting like, okay, how do we get down from here? The robot's really like, oh my God, I'm gonna fall. I'm gonna fall. So that's one of those tools that you don't want to have to run, but when it runs and it works, it's like, that's awesome. It's so nice that we put months into this.
There was an amazing moment that you probably didn't see here. When we came out of the building, we planned a long footstep plan to go to the ladder and hit execute, and we had total network silence.
Radio.
And so we were all like, what's going on? And then all of a sudden the radios come back up and the robots attack the ladder. We're all like, yeah!
We just kept going.
Yeah, if you only walked halfway, maybe you would have just remained in that blackout area.
That would have been nasty.
I'm glad you didn't quit the stairs.
Yeah.
Could be rough, man. I liked walking robots, and that was our chance to shine at the end. But it was just one little drill slip away from potentially winning the whole competition. I think we got to show the world that a robot based very much on autonomy was capable of competing with the very best robots in the whole world.
I think this competition showed a good spectrum of robots that are from the ones that are walking very slowly and very carefully with very old school walking techniques to, hopefully this isn't too egotistical, but more advanced people like us who are walking with more novel, kind of very custom controllers that are moving the robot in more elegant and a lot faster and cooler ways.
I'm extremely proud of the team. We've been working absolutely around the clock this week. We faced all sorts of problems. We've addressed them with dignity and intelligence, and I'm just so proud.
I'm early enough in my graduate career that I don't really know what I'm going to focus on in terms of like PhD. I know I want to do robotics, and I'm really loving all this walking and recovery work that I've been doing. So I think seeing recovery work on this terrain is perhaps some encouragement, and I'm going to keep looking at this recovery and walking stuff.
Guys, walk naturally.
I'm going to use that.